Good morning, everyone. Welcome to the July edition of the Optical LAN webinar. Today, we're going to talk about passive optical LAN, some of the challenges and some of the successes. My name is Brian Hardy, but before we talk about me, I want to go over our panelists and talk a little bit about them. So our panelists today are let me back up a little bit. So there are a couple of components of passive optical LAN. We have our active and our passive components, and then we have designers, we have integrators, and we have manufacturers. So today, we're bringing you a kind of a variety of designers, integrators, manufacturers amongst the passive and active parts of Optical LAN. So with that, we're going to bring in John Tumajan, who is with Optical Cable Corporation, Blaine Overstreet, who's with AECOM, Scott McIsaac, who is with Telabs, and Matt Miller, who is with AECOM. Some of the learning objectives that we're going to go over are some of the technology challenges. So a lot of people talk about how we get into passive optical LAN installation. What are some of the pros and cons? What are some of the blocks to the passive optical LAN cell? So we'll try to cover some of those. How passive optical LAN solves unique business problems. We're going to cover a lot of that. What I like to see is a unique challenge that's presented in a customer environment, and then how passive optical LAN can solve that business case. Some other use case examples. So we're going to talk about some of the kind of cool installations that all of us have gone through, and then some of the best practices and innovations that we've run across in our careers. So without further ado, I'm going to introduce all of our panelists formally here. So my name is Brian Hardy. I've had over 25 years in the technology, architecture, and consulting. My background is more on the engineering side, route switch, security, kind of once you put it passive optical LAN in your network, how do you make it work with the network, and how do you make sure that that installation is successful? I've been with the association. I'm probably one of the newbies of the association, but I've been with it since 2016. I'm the current treasurer and technology committee chair. And then for next year, I'm the president-elect. The next person I'd like to introduce is John Tumajan. He's with Optical Cable Corporation. So as we mentioned earlier, we have these different components. We have designers, installation, and manufacturers. John is a manufacturer for some of the fiber passive components. He has over 28 years experience in infrastructure sales support and design, in optical LAN development, and he's a member of our technology committee. So welcome, John. Next after John, we have Blaine Overstreet. So Blaine is with AECOM. He's an integrator. So he has over 3 decades. I can't really count that high. I stopped at 25, but I guess he's a little bit past me there. But I'm rounding up. The cool thing about Blaine is that he was a lead engineer on one of the first passive optical LAN deployments back in 2008. And he's installed thousands of these in all of the vertical markets. I'm just going to say that. He's also a founding former director and former chair. He also sits on the technology committee. So welcome, Blaine. Thank you. Next up, we have Scott McIsaac. He is with Telabs, their manufacturer of one of the active components. He also has over 30 years. He just likes to say 30 instead of 3 decades in the telecom industry. 18 years with Telabs supporting telco and enterprise environment, and he has been involved with the passive optical LAN technology over his whole career, but he's kind of moved into the enterprise market there at Telabs. And he's new to the Optical LAN, and we actually welcome him. He's kind of I think a couple of months in, so he was one of the folks that volunteered for this, and thank you, Scott, for doing so. Last but not least, who I like to say is our special guest, our director from last year for the whole association. That's Matt Miller. He's with AECOM. He's also a passive optical LAN integrator. He has over 20 years experience in systems and network engineering. So I feel like we can talk kind of the same language there, whereas other folks maybe talk a little bit different. He's also worked with passive optical LAN since its inception. He's done a ton of cool projects and installed hundreds of thousands of Ethernet ports over PON-based Ethernet ports. He also was the past chair and technology committee chair, and he's helped significantly with my transition into that current role. So thank you, Matt.
Morning.
Good morning. All right, so the technology committee wanted to put this presentation on to kind of get a more in-depth of an engineering type of a roundtable about what are some of the practical installation experiences that we've all had within the passive optical LAN. I know everybody loves the slides that we present, kind of how it works, how it integrates. But we wanted to talk today a little bit more about once you plug it in, what happens? What are some of the challenges that we've run into? What are some of the kind of innovative solutions that POL has brought to the table that maybe a customer didn't know about until we actually brought it up? So with that, I would like to start with, let's start with John. I'll pick on John for a minute. So John, your bio, you've been doing this for 28 years and you're a manufacturer of some of the fiber components. Maybe you can just talk a little bit about what the actual passive layer is, kind of what it does, and let's start there.
Sure. Thanks, Brian. So from a physical layer, passive layer perspective, in traditional fiber, we would do 2 strands of fiber, a transmit and receive, and to a device, and then copper out from there. Where passive optical LAN is different is we use a single strand of single mode. And so you'll do transmit and receive on that single strand. The other benefit of that is the distances that you can go. So typically with a traditional LAN, you'll need to build a telecom space for every 10,000 feet service. The reason for that is that's the reach of copper, your 90 meters or 295 feet. With passive optical LAN, from the OLT, the head-end layer 2 switch, to the ONT through the splitter, you can go up to 12.5 miles. So it gives you a lot of flexibility that you don't have to build these telecom spaces. You can basically eliminate them. You can build them, but from a passive optical LAN perspective, we don't need that. The other thing I think that's very, very compelling is there's really no bandwidth limitation. I Googled how fast have they gone on fiber optic cable this morning, and it was 128 terabits.
Wow.
That's 128,000 gigabits. They said you can download the entire library of Netflix in 1 second. So if you look at your physical layer, and everybody's been doing tech refreshes every so many years, Cat 5, Cat 5e, 6, 6a. With single mode, it's treated more as a permanent infrastructure of the building. Right. So
and the numbers that you were talking about as it relates to the maximum that they've tested, that's because just the equipment that they can send to test is only reaches that. So it basically, the fastest equipment that they were able to produce a test was that number, but that it didn't fail, which means they just need to make faster equipment. So that's why a little bit why you were talking about the permanence. So let me pause you there for a second. So Blaine, I'm going to have you put on your get in your time machine, go back to your first passive optical LAN, because it sounds like your first passive optical LAN deployment, because it sounds like maybe some of the benefits of single mode fiber that John was just talking about was probably the reason for putting in one of those first passive optical LAN environments in the infrastructure. So if you can talk a little bit about kind of the first ones that you went through, and then I don't know if you're still aware of that particular customer today, or maybe one of your first customers. Kind of fast forward to, are they still using it today, and are they just swapping out ONTs for performance increases?
Yeah, it was a federal contracting location, so there was some sensitive work being done at that facility, so I can't share a lot of details about it. But one of the big takeaways from that deployment was, first and foremost, it was the first passive optical LAN as far as we're aware of. There's been some anecdotal information that somebody may have tried different optical technologies, but as far as we know, it was the first one where we engaged. We worked with Verizon Federal Network Services at the time to engage manufacturers to try to get this, including Telabs and Motorola. It really, in those days, and this was around 2006, it wasn't really ready for enterprise work. But what it was able to do was deploy a pure fiber solution, which was you just can't do that in as a pure practice in a design. That is, you need that copper connectivity extending from the workgroup switches. The practice of putting multi-mode fiber NICs in computers had been largely frowned upon at that point. Certainly it was done, but the cost of all that was really going to end up being these multiple classifications of networks in closets. So what that did was add huge cost to the construction, to the integration of the technology, having multiple networks like that. What passive optical LAN allowed at that time was 90% fiber. And the other big takeaway from that deployment is that it's still there. That network is still operating. We turned it up in 2008, and it's still humming away. Same equipment. Been a couple of upgrades along the way, but that's just a testament. And one of the key things that we sold that solution on was that it was going to be a lot longer enjoyment of the network equipment and less refresh over the years, and that certainly has been the case.
Okay. Let's have Scott jump in here for a second. So Scott, you've been with your current company for about 18 years, but you've been in the industry for over 30 years. So maybe you can give us perspective of kind of the evolution that you've seen change just within that 30-year span, and with going from your company from maybe one division to another.
Absolutely. Yeah, I started back in the late 80s working for a small eyeball. The thing back then was bandwidth 1.5 megabits. Right, that's what everybody was doing. That was the big thing. You had to be a special person in order to work on it, install it, or use it. It just wasn't high bandwidth demands, or there wasn't equipment that could support high bandwidth. So as time evolved and things went on, and you still even saw the user end equipment. I remember PC Magazine writing an article back in the late 90s where they were saying, "Oh, all you'll ever need is 4 meg of RAM." I mean, you put in 16 gigs of RAM in most computers today if you walk into a Costco to buy. So as technology changed, the needs and demands changed along with it. So as we progressed and started putting in more and more muxes throughout different companies' networks just to provide bandwidth to that company, you could see that scalability going from the 1.5 megabit to the 100 meg to the 1 gig, and then eventually 10 gig. And even when 10 gig kind of came out, people were like, "What do I need 10 gig? I'm never going to need that kind of bandwidth. It's just ridiculous." But when it became a pricing exercise, and the different companies could now lower that price structure so that 10 gig was reasonable, you could actually buy a 10 gig wave for the same price as a 1 gig EPL, there was no reason not to try it. And then once they got it, they were shocked by the fact of, well, look at how many more applications we can actually deploy now, because we have this unbelievable amount of bandwidth. So then the challenge became, how do I extend that to everybody? Whether it's from the broadband side or physically the local area aspect, as we're talking here today, if I can bring in massive amounts of bandwidth into a building, how do I extend it through the building, or through a campus, or a smart city, or an airport, which really is a smart city if you think of it, right? It's so large in scale, as Tom mentioned, that distance that I can extend my network. And you've just eliminated all these obstacles that you've had in the past. So it's really gone leaps and bounds from 1.5 meg to 10 gig to 100 gig to 400 to terabit, just in the bandwidth that's being brought to our customers today. Now we want to share that with them. And having this kind of flexibility with these kinds of products, I started doing FiOS when it came out in the 2003 time frame. So I was playing around with a couple of different manufacturers, products, and it was so cool because it was just such a leap to get away from that, 1 meg service or less, to be able to offer 5 meg. And very quickly they scaled to 10 to 50. Now everybody's offering a gig just from a broadband perspective. Now, again, how do I get it to my customers in my buildings? These customers need more. It just gives you just that great flexibility. I'm just beside myself, but I love it. It's been a great learning experience, and it's a lot of fun to see how technology moves, adds, and changes to adapt to what everybody's particular needs are. I mean, you can use this anywhere.
Yeah, absolutely. And I always joke with folks when I started working with Passive Optical LAN in 2012. I felt that the systems were, you had 3 options: large, extra large, and extra extra large, because of the amount of Ethernet ports that you could get into. It's almost like a competition: who can get the most Ethernet ports into the smallest amount of the chassis space. And speaking of hundreds of thousands of Ethernet ports, Matt, you've been around for a while, installing Passive Optical LAN since, I believe, 2006. And maybe you can talk a little bit about, from the integrator standpoint. I'm sure you had to right size systems, and you've deployed all of these Ethernet ports, and maybe just talk a little bit about the evolution that you've seen within your experience.
Yeah, it's kind of funny because we have been doing this for quite some time, and we've seen the technology progress quite a bit. I like John's comment about Googling, what the bandwidth of the fiber is today, because I do a lot of training courses on this material, and I do the same thing before I present, because it evolves so quickly that you do have to Google it that day to see, oh, what are they pushing over the fiber today, because it just continues to increase. But in terms of the equipment, we've definitely seen leaps and bounds of improvements of the equipment in orienting it toward the enterprise. When we started this whole thing, gosh, 15 years ago now, it's been, it was kind of shoehorning the technology into the enterprise environment. There were some things that weren't made for the enterprise that were specially designed specifically for the carriers to isolate traffic and do some things that they want to do with the traffic. So we had to work with the manufacturers to get the equipment adapted. But now what we have is a very rich ecosystem of equipment and capabilities across a large number of manufacturers that have realized that the enterprise really is a great environment for this technology.
Yeah, absolutely. I mean, I think it's come a long way. I've my kids, I talk to my kids about, how the internet's connected, and it even fascinates them that, hey, we're actually connected to all these continents through actual physical cable. And, the amount of effort that it takes to put those cables in the ground or in the ocean, and, like the amount of speed that can go across it is a great innovative technology that was made at the time. So let's pivot a little bit, and let's talk about maybe some of the unique challenges that came up. So we're all kind of engineers on this in one facet or another, whether on the integration side or on the manufacturer side, whether it be active or passive. what are some of the unique challenges that have come up, maybe some barriers to entry into the market that we had to discuss and bring to a customer? So maybe let's start with Blaine this time. So I'm sure some customers said, hey, maybe I'm not ready. What are some of the reasons, and kind of what are some of the solutions you put in place to convert that customer?
Yes, so it's somewhat cliche to mention this one, because if anybody's initiated in passive optical LAN, they hear it quite a bit, but really the biggest challenge is selling against the present mode of operation. So Ethernet networks based on traditional switches, that paradigm of the telecommunications closet and 300 feet to the desktop, that works. No one here at Apple is going to say that that infrastructure is somehow deficient or inefficient, but in comparison to passive optical LAN, the advantages are considerable. But there's definitely an embedded concept or mindset in particularly experienced network engineers that have been around for years. They have their certifications, they have their, they may be an RCDD, what have you. They're embedded in that so much that it's difficult for them to actually look at a disruptive technology like passive optical LAN and make that jump. They'll have lots of questions, and that's what we're here for at Apple, is to help educate customers on that, because there are some complex concerns and valid concerns, and you just have to put them out on the table.
Sure. So speaking of RCDD and traditional Ethernet, I'm gonna ask John a question. So, your sales model went from selling single mode fiber to extend to IDFs, or MDF to IDF, or TR to ER, whatever the terminology is these days, to taking that same one, but now putting a device on it that can split it into a bunch of other fibers. How was your transition to selling to customers with that technology?
My original transition was, should somebody do this? And then the more you dig into it and experience it and learn about it, you start coming to the conclusion of why you shouldn't do this. Why shouldn't I do this? Right. And with 28 years in the industry, I've been through a lot of, physical layer refreshes, Cat 3, Cat 4 for a blip, 5, 5E, 6, 6A. What's after 6A? I know Cat 8 for data centers, right? And when you start looking at this, and we just mentioned the bandwidth, right? We're looking at putting in a permanent building infrastructure, right? The electrical system, the plumbing system, the foundation. Well, this is permanent for single mode. And so for me, when people start looking at that, okay, we might replace the endpoints and upgrade them from gig to 10 gig. It's 40 gig, 100 gig, so on with passive optical LAN. The one thing that's constant is that single strand of single mode. That won't change. And so that, to me, that's very, very compelling.
Yeah, absolutely. Whoa, a lot of echo there. Okay, so one of the things that I was thinking when you were talking about that is kind of the end user. So you have regular Ethernet, active Ethernet. You have your two ends. You have your single mode in the middle. And to upgrade, you just kind of start swapping SFPs. You got your 1 gig SFPs, and you got 10, then you got 40, and then you got 100, and you keep going. So Matt, with some of the kind of integrations that you've done, how have you kind of convinced your customers that, okay, well, instead of going that route where you just swap out SFPs for these end switches, let's put in this new technology, and kind of what was their take back from that pitch?
Yeah, it's kind of interesting because every customer has unique challenges that they're looking to solve, right? I mean, for some, it's very simple, right? I want to save money. So this solution is cheaper, so I want to do that, right? That's the easy one. But sometimes people have other constraints. It could be that they have power issues, right? It's a historic building. They have no way to bring in power, or closets are an issue, right? Maybe it's new construction or existing construction, and they just don't have the closet space to build a TR that's filled up with switches, right? And the other one is energy. We see a lot of folks that are looking toward the green aspect of things. We know it's an overused term, but you know, with the consideration for LEED certified buildings, or just the desire to make an impact on the environment in some way, where I'm not putting in, you know, one of our larger installations, we calculated that it was 8 tons of copper that was going to be put into that building. So when you think about that, that copper, that precious commodity that continues to go up in price versus, you know, sand, which we have plenty of at the moment, that's kind of a big deal, right, for a lot of people. So it seems to depend on the user, but we see a lot of different reasons depending on who they are.
So Matt or John, this question is for you, and it's on the design. So we've kind of talked a little bit about some of the different components, but on the design, how do you take that where an architect already has, you know, pathways and conduits built to TRs and ERs, and you have, you know, these massive, you know, 4-inch conduits, and then you're saying, well, I'm going to put like 12 strands of fiber through that. And we've all seen them in pictures because they're part of the marketing material, but it is actually true in real life. Like, do you all see a transition at some point where the architects are going to start maybe integrating some of this within their design? So they're, you know, because it's almost like this is the way we design buildings. Every building will have a TR every 300 feet, and you know that's not necessary anymore. So like, just maybe a little bit about your experience about running into those challenges.
Go ahead, Matt. I think anytime you can tell an architect that they could reclaim space, they're pretty thrilled about that. And also, if you look at an existing, you know, building and your conduit fill ratios, and you're upgrading, let's say from 5E to 6 or 6A, and you've got so much conduit, and the fill ratio just won't support that larger copper conductor. Where if you're running a single strand of single mode to a 4 8-port ONT versus 4 8 copper drops, that's pretty compelling. So I think just from CapEx, from new installation, right? From you know, your cable supports, your cable tray, it may not be tray, it could be J hooks, right? Well, there's a huge savings there. So just from, you know, looking at from that standpoint, I'm running a single strand, a single mode to a 4 8-port device versus 4 8 cables. That it's pretty compelling.
Yeah, I've found that we are, geez, lots of noise there. I've found that we are an architect's best friend, right? With this technology, when we come in and say, well, what if we could get rid of the closet entirely? They jump on that, right? And the developers too, right? Where that square footage equals money, right? Very palatable money. When we can go to them and say, we're going to save you 100 square feet per floor or whatever it is, that's a big deal to them, right? And they recognize that and they latch on to that, and they usually won't release it once they've realized that benefit. You know, it's like, no, the next building, we're not doing this again. We're not building closets anymore, or whatever it is, right? Whatever benefit they've latched onto, but certainly the space is the big one. And it's funny because now we've gotten many of the low voltage designers understand what those benefits are. You know, we've done so many designs where it starts out as a 18 or 24-inch, you know, cable tray up in the ceiling, and you say, well, no, you can really reduce that. You know, we need less than an inch, so you know, put in 4-inch, and that'll be overkill, right? And then they say, well, let's do 12-inch, right, just to be safe, you know. And then you go back and look at it when it's all done, and there's, you know, 1/2 inch cable in that cable tray, right? That's a big deal, right? So it does make a difference.
Yeah, exactly. Scott, what's your take on it? Do you see maybe that some of the designers and architect firms are actually designing buildings maybe differently now because they can do kind of this open architecture that everybody likes from watching all the home and garden TV shows? where you have these big, massive open rooms and high ceilings, industrial looking, that nobody wants to see a big bundle of cable running through. Are you seeing architects and engineers designing differently because of the benefits that passive optical LAN brings?
Oh, absolutely. I mean, everything's about education, right? So we struggled from the beginning to get the message out, get everybody on board to kind of see the benefits. But there's always that hesitation, and they don't really want to buy it. I mean, same things that Tom and Brian were mentioning. You know, as I'm trying to change my fill rates and so on, you still wanted to go to the 12-inch tray when you only needed 1.5 inches. So it's the believability behind it. But once they have latched on, as Brian had mentioned, it's amazing where they can see how they can change the entire structure of that building. So their architectural design now becomes more form factor and grace and design and artistic, rather than, oh shoot, I gotta cap it here, I gotta stop there. Or just a transition from indoor to outdoor. You know, as I'm trying to do these things, my fiber can extend outside a lot easier than I can with copper, just from a lighting perspective. So now if I have to put equipment out in a parking lot somewhere, or a garden, if you will, it's a pedestal or a post rather than a whole pad to house active gear in. So you just really change the whole landscape of what they can do. I've seen a lot of excitement behind that. I think, Brian, you mentioned the low voltage aspect of things too, especially you see low voltage lighting really coming into play now in architectural design, because you're doing PoE off of all the devices as well. So now you've changed how much power is really being used, the way that light can be designed, the type of light that can be used, and where it can be placed, the distances it can be placed. It's just, you're building the highway, right? You're laying that fiber day one, as Tom mentioned. So I built this unbelievable highway. Now I'm just putting a faster car on each time, or a car with new features. So it's, the next Elon Musk car, or whoever's going to come out with the next electronic car. It's the same thing. Like, what's that next evolution I go to? You've taken away all those restrictions for people. It's cool.
So you're saying Tesla's going to jump into the passive optical LAN market, huh? So the one thing I do want to bring up when you bring up PoE and just kind of how the technology allows other companies to innovate, like remote powering, that brings a completely new solution to the table that a lot of people haven't thought of. In my experience, a lot of times we'll put in systems, we'll put in a DC power plant, that also doesn't require as much cabling, but it keeps the network up for a significant amount of time, so much so that a lot of other departments within organizations that we install are like, hey, can I tap into that DC power plant for survivability purposes? Because, it's great that the wireless and the phones are up and running, but it'd be really nice if that router at the site could still stay up, so that it's adding kind of the different layers, or saying, hey, wait a minute, maybe I want to tap my HVAC and remote power some of the stuff that were traditionally 2 wires into the DC power plant. And it just kind of opens it up. You mentioned remote lighting. That's absolutely one of them. Distributed antenna systems and extending Ethernet port, really far. Maybe you have a facility that has an extremely long driveway that's a couple of miles, and you need cameras at the end of it to protect folks coming in. Well, you can actually tap them right in, because if it's a wireless connection, I've seen some where the wireless AP that's on that camera has a couple bullet holes in it. So, you can look at some of these new ways to implement passive optical LAN to solve some of these business problems that weren't there. So, or that they didn't know that there was a solution to that was a little bit more secure. So speaking of that, and some of the more innovative approaches and use cases, because we're going to wrap those two together. We'll go kind of through each one of you. Maybe think of a use case or a problem that one of your customers had that you were able to get passive optical LAN to solve that problem, or like maybe a really cool install that was done that that you think that this forum could benefit from hearing? Do you have any volunteers to go first, or do I need to pick somebody?
Sure, I'll go first, Brian.
All right, John.
So one of the cooler installations is an RV park. And this is a quite large one. The first phase of it's 500 stalls. And it's where folks would stay for several months. And it was really a passive optical LAN, because of the sheer size and scale of it, was just a perfect application because of the reach. They're putting an ONT on the pedestal for each stall. And so they could remotely manage it. They could deploy splitters, because a passive optical LAN is not a point-to-point technology. It's a point-to-multipoint, using a 1x32 splitter as an example. 1 in, 32 out, so you could support 32 stalls. So it made it just a really cool installation, and it's really, yeah, with the distances and able to, centrally manage everything and give each user, whatever bandwidth they needed or wanted. It was,
yeah. I would suspect with the amount of folks that have been working remotely with COVID that are, in the wilderness somewhere, but can still tap into be present for their meetings. I bet that's a great benefit as well.
And I'm working on another RV park, and it's smaller, where you would stay, a couple days or a week. It's more on a national scale, and putting in, bandwidth there at each stall wasn't really the RV park saying, yeah, we want to do this. This was a demand from their customers to say, we need this. Right. Because now you look at it, if you stay in a hotel and they don't have good bandwidth, you probably stay in a different hotel. And so it's really the RV park from customers demanding that bandwidth. So yeah, so a couple pretty cool installations.
Yeah, plus revenue generation, I would imagine, for the that's a revenue opportunity, because they become a service provider and they can sell internet and based on how much you need. Yeah. Scott, what about you?
I like the airports, because again, to me, it's really its own city. You're kind of hitting almost every aspect of why, like to Tom's point earlier, why wouldn't you do this rather than why would I do this? So now I've got my reach capabilities to hit the ends of the runway. You're talking acres and acres of property you're trying to reach, and you've eliminated every closet that was ever required in the past. So just the savings of that space, let alone the equipment that would have had to go with those spaces too. Every evolution we go through, there's always some new need or requirement by those customers. So it's the convergence of all the different technologies that you can layer one on top of the other and still do it over a single fiber path. And then again, it's just, I don't know, it's that whole smart city, because you've got every customer aspect going on, multiple businesses running in that same environment, and yet you can still treat them as separate entities and still be able to manage it all from one console. So the amount of support and services that you can provide to those end users, your customers of the airport, so that they can support their customers. So you talked earlier about large scale deployments. This is a whole bunch of small scale deployments within a large scale deployment, right? So I'm now treating that, McDonald's, the customers I can't say, the Arby's, the whatever little restaurant that's there, where before I needed to have so many X number of Ethernet ports in order to justify the means. Now I can hit every aspect, and we're constantly all developing technology and methods to make that better and better and more cost effective. It hits every aspect. It's just
right.
It's the architectural design, as you mentioned earlier, because now you build the building the way you want it to look rather than the way you had to have it look. We're dealing with a whole bunch of different airports now that we're running into these things, and each one has their own little challenge and they have their own desires. So yeah, your engineers have to go back to the drawing board and work a little harder to fit some stuff in, but the technology allows that to happen. Again, limitless applications.
Okay, great information. What about you, Blaine?
Well, kind of dovetailing onto that concept where in the RV park, is spread out over long distances. We had an interesting project, a fun project that Matt and I worked on a couple of years ago. It was in the Costa Rican rainforest, an educational and research campus, literally in the very remote mountainous area of Costa Rica. Their historical approach to the network was put a fiber in from the main building to the next building, put it in a switch, take some copper, buried it in a conduit to the next little building. For one thing, it wasn't something an RCDD would have designed at all, but they had huge service issues with that. They were using consumer-based switches, they were using enterprise-based switches, and it was just a big mess. And they certainly suffered for that over the years, particularly in the climate down there with a lot of rain and moisture and so forth. So when we proposed passive optical LAN, it actually checked all the boxes for them. And we're talking about nearly 36 buildings scattered over, I don't even know how, I think it was 15 to 20 acres, really spread out longitudinally, not a square, but spread out quite a bit. So that presented huge challenges for that type of deployment, and passive optical LAN was perfect for it because it gave them more than enough bandwidth, but they were actually putting just a small 4-port, 8-port device here and there that actually served the needs for that small, classroom or a cafeteria, what have you. It was actually a really good application for them, and they're seeing the benefits of it now. Everybody's connecting to the network seamlessly instead of going up to the main office asking, what's wrong with the network? Well, it's down, for a few minutes. So, they are at the end of the day are a business, and they saw a huge impact to their business as a result of it with the customer success.
Yeah, I think you guys won an Appleland award for that. But between us, we'll keep it that you guys were working in Costa Rica.
We did see some monkeys. It's interesting when you go on a dirt road and you see a monkey crossing sign. That's not something Americans are used to.
All right, Matt, what about you? Kind of innovative and unique installations.
Yeah.
Other than when you were working in Costa Rica.
Right. Well, yeah, I mean, we see a lot of education, not just in the rainforest, but even in your traditional education, both K-12 and higher education. The application is very apparent there. I see one of our attendees even mentioned some K-12 schools that they're doing designs for. We're also seeing a lot in the K-12 and higher ed market. When you think about higher education, it is a city, right? It is a city and it is an enterprise kind of combined. And that really is kind of the best of both worlds in terms of what passive optical LAN, passive optical networking are. So combine that with the triple play services, the voice, data, and video that you're typically delivering to classrooms, administrative offices, residences, it makes a whole lot of sense. So we're seeing a lot of traction in that area because they have unique problems. We did a different higher education campus where they have over 600 buildings, right? Because they're a large campus spread across many acres, and that includes, outbuildings like horse stables, right? And when you think about how to bring Ethernet into a horse stable, you can think of a lot of problems there, right? But with passive optical LAN, guess what? You've got that outdoor ONT that's meant to be mounted on the outside of a house. So there you go, screw it on and you're good to go. So it can solve a lot of those unique problems.
Yeah, one last thing I want to cover before we go into questions and answers is upgrades to faster speeds. So, upgrading from, I guess, traditional GPON to faster speeds that different manufacturers support. Maybe just kind of really quick, because maybe a minute or two per person. John, what needs to be done from a cable manufacturer standpoint to do that upgrade to get faster speeds? Do you need to do anything from a cabling standpoint?
Nothing. You're good to go.
Okay, so got the cabling, got the single mode fiber, we got our splitters, we're out to the ONTs, we have our head end equipment, we have our ONTs. Blaine, what do we need to do to upgrade to 10 gig at the user location?
Yeah, so that existing investment in the optical line terminal, that head end of your network, it still remains. In fact, you can still use those, I'll call them legacy GPON 2.5 gig PON port cards, continue to serve the ONTs you want, but you can backfill into that same chassis with a 10 gig line card that then connects to 10 gig ONT. So you can actually migrate to 10 gig seamlessly just by putting the electronics where you need it. It's not a one size all approach. So having 2.5 gig GPON and 10 gig within the same chassis is certainly doable.
Okay, Scott, what about you from a manufacturer standpoint?
Absolutely, to resonate on what you just mentioned. You may have to do some type of coexistence module so that you could blend wavelengths over that same existing fiber that Tom mentioned didn't need to be changed. So I don't have to build another network on top of it and building a virtual network on top of it by just adding a wavelength into that picture. So yeah, the ONT may change at the end. As Blaine mentioned, I'm changing a GPON card to a 10 gig card or whatever the next evolution is going to be based on customer needs and demand. But it really, again, just makes it very flexible. So the simplicity behind this whole network, you built that highway day one, then it's just change the card type or the optics type or add the coexistence module so I can blend wavelengths together and share that space. You've treated this whole thing like almost like a DWDM system where I can do multiple wavelengths and just get unlimited bandwidth everywhere. And you don't have to dedicate 10 gig to everybody. It might be a rolled migration. So a couple of customers will stay on the GPON network because of their bandwidth needs. I think probably one of the biggest drivers today is probably Wi-Fi 6 is demanding a 10 gig pipe, but I don't have a 10 gig user on it. I just have a lot of users trying to use a bigger pipe. So it gives you that flexibility as well.
Okay, so Matt, basically what I'm hearing is I don't have to swap out the infrastructure. That's probably what they call future-proof. And then if I'm in like K-12 and my teacher wants to, for whatever reason, they need to watch a lot of YouTube for classes and I need a bigger ONT, I just unplug and plug in a faster ONT. And a hotel, if they ever upgrade, if they budget to upgrade, I don't have to shut down a whole wing. I can actually just go into a room at a time, maybe when they check out and swap the ONT or something like that. Is that kind of what I'm hearing?
Yeah, it's funny because we've had some installs that have been around for some time now, a decade plus, and they're looking at upgrading just for the same reason Scott mentioned, right? They're going to Wi-Fi 6. They need that 2.5, 5, 10 gig to the wireless access point across all industries, hospitality, enterprise, you name it. But 10 years later, they come to us and they say, well, we want to upgrade. And we remember that you said this is future proof. Do we really not have to replace the fiber? And we say, you really don't have to replace the fiber. Just switch the electronics on the end and you're good to go. And you can do it at your pace.
Yep, absolutely. Okay, so that's going to kind of wrap up our roundtable session. We're going to get to questions in another couple of minutes here. What we have a few that have come in, so take this opportunity to write down some questions, and we're going to just talk a little bit about the association. I'm going to ask Matt if he can kind of just go over what the association is, some of our members, and what you can do to join.
Yeah, thanks. Yeah, so please type in some questions if you have them while I'm talking here. So the presentation is brought to you by the Association for Passive Optical LAN. We're a nonprofit organization. We're made up of all parts of the industry, like Brian said, right? The manufacturers, the integrators, the distributors, all pieces that make up the passive optical LAN. We're here to educate and advocate for the industry. Obviously, you can see that all the panelists here our hearts are in it, right? We really do believe in this technology. If you're one of those folks, we'd love to have you on board because we're always at events trying to get the word out and help others. We know it is a new technology, so there's lots of questions that come with it, right? Here's our membership base. We have membership levels starting at the associate level for small companies, all the way up to the platinum members that are influencers in the industry. And of course, benefits come at each level. So yeah, like I said, please join us if you're one of those companies that believes in this technology or is just interested in it, wants to learn more or participate. We have a number of committees. This is the technology that's presenting to you right now, but we have a marketing committee, a membership committee. We have a European committee for the Europe market. So there's lots of opportunity to participate.
Thank you, Matt. Okay, so we have some questions. I'll run through them, and let's see if somebody can just start talking and cut me off here. All right. Somebody wants to know whether PON supports dedicated 10 gig for each device and how it can support 10 gig for all the remote devices. So maybe talk about a little bit about the architecture to support a 10 gig.
This is Blaine. I'll go. So certainly if you want to extend 10 gig and dedicate it to, say, a server or some high bandwidth application somewhere, or yes, we're just talking maybe a Wi-Fi 6 application, you can certainly do that. You can take a individual PON port on the chassis and dedicate it to an endpoint with a dedicated ONT. You can do that, but the advantages are in that passive split in the midspan of the network, certainly being able to leverage that optic for multiple endpoints. But there's certainly nothing to prevent you from dedicating that PON port. And in fact, you could even bypass the PON port and extend from the uplink card a 10 gig connection directly to the endpoint. So you don't necessarily have to go through the PON conversion. You're going straight Ethernet port out to the end, just like you might do with a workgroup switch.
All right, thank you. Next question. I get this one actually a lot because there's a lot of different acronyms that are thrown around. So the question is, how is passive optical LAN different from PON, different from passive optical network, EPON, GPON, and GPON? So I'll start it off, somebody else can jump in. So passive optical LAN and passive optical network are two different ways of saying the exact same thing. When you get into the EPON, GPON, and GPON, that's where you have different types of implementations. And who wants to cover that one?
I'm glad to cover that one.
Thanks.
Yeah, so we hit this one a lot in a lot of the Bixby training classes and other venues because that's probably our biggest issue as an industry is our acronyms, is that we have so many of them. So yeah, beyond the OLT and ONT, all of the acronyms that describe the various versions of the technology. So I'll try to keep it fairly simple here. EPON is a IEEE standard that we don't see in the LAN side of things used very often. What we do see very commonly are GPON, which is the 2.5 gig standard. We see XGS-PON, which is the 10 gig symmetrical. We see NG-PON 2 as the future. That is the standard that brings us to 40 gig. There were some other iterations along the way that all were evolutions of speed and whatnot, but those are certainly the ones we're seeing most commonly.
Okay, next question is, I can tell this is from an engineer. Why not use point-to-point Ethernet cards in the OLT and point-to-point Ethernet ONTs instead of PON? You still have to install vertical cable with more fibers, larger building distributors, floor splitters are eliminated. So kind of in general, why as an engineer would you say, let's go with a PON solution versus active Ethernet point to point? And in some instances, by the way, you may opt for both. Anybody want to field that?
Well, this is Blaine. I'll go again. So it's true that it seems somewhat straightforward just to continue an optical Ethernet interface straight to the endpoint. The beauty of passive optical LAN, though, is you're really not going in and configuring GPON or the XGS-PON protocol, and anyway, that's really kind of baked in to the technology. You're still dealing with terms like VLAN and you know, it is an Ethernet switching mechanism. The way it gets encapsulated from point A to point B is very different from Ethernet. But it's not the job of the operator to actually try to navigate the complexities of PON technology itself. That's just simply a function of the manufacturer's engineering and the optics. As far as the splitters are concerned, those are passive. They sit in the ceilings, they sit in the wherever they happen to be mounted in an enclosure, an electrical room, wherever you put them on day one, that's where they'll be on day 10,000. The concern that perhaps the fiber could be broken is valid. It can happen from time to time, people snipping the wrong cables during refurbishments, what have you. To the extent you do that today in a traditional network where you want to have a redundant path, you can do that with a PON network as well. A passive optical LAN allows you to have an active and a standby PON port. So if a fiber did get cut, you're actually extending to a 2x32 splitter, typically, that will give you that active standby capability.
And it switches at the speed of light.
Less than 50 milliseconds, yeah.
Yep. Okay, maybe this one is for John. Well, actually, it's probably in general, but it's probably when, John, you were talking about the RV park. So they're asking, do the ONTs have Wi-Fi APs built in? So I know a lot of different manufacturers do a lot of different things, but maybe you talk a little bit about that.
No, they didn't. What the RV park did is issued them like a wireless router that would put inside their RV. So they would just run a rugged copper cable from the ONT at the pedestal into their vehicle, and then just plug in the wireless router. And so that was their connectivity. It was pre-configured with the SSID and everything for them.
Okay.
Well, it changes so much. Why would you want to commit to a specific Wi-Fi technology where it's changing so rapidly? 7's coming out within a couple of years, 8 coming out in a couple of years after that. Now you've kind of stranded that into the ONT, where kind of keeping them separate, at least this is my view anyways, keeping them separate, I can still maintain a pipe or easily change an optic to address a greater pipe need, and then not have to change the other parts. But combining them together, I think you might be stranding some of your investments. So I like the flexibility, like John mentioned, of having the separate devices.
Yeah, and again, I think that's where you may see different manufacturers doing it different ways, but I think that's also the benefit of the technology. You see a lot of different ways to implement things. You know, I always tell folks, you know, there's 100 different ways to engineer things. Probably even 70, 80 of them are the correct way. But you got to know your customer. You have to know their challenges. You have to know what they want to do in the next 10 years, and you start scaling those down into a much more manageable number of solutions for them. So, you know, maybe again, we talked about revenue streams for the RV park. Maybe they want to at some point say, okay, I can give you a little bit faster connection. So I want to design it and implement it this way, where I give you a physical handoff versus just connecting to the normal Wi-Fi. So there's a lot of different ways to design. Let me get this one last question about DC power schemes. Could there be a future best practices session? So we're Association for Passive Optical LAN. Remote power is one of our kind of add-on things that's done. What we could probably do is possibly get another panel going with some additional manufacturers, some additional integrators, and maybe go a little bit more into some of those additional things, even some that were mentioned today, such as like the extension of PoE lighting and DAS and DC power. So maybe we can get to that in the future. So with that, I would absolutely like to thank our panelists for volunteering, some not so willingly, but I appreciate all of your volunteering for the call today. I would also like to thank John Hoover for helping with the marketing committee with helping me get this put together. If you need to contact us, you can send an email to contact@applelandglobal applelandglobal.org. You can go to our website, www.applelandglobal.org. There's going to be a post-webinar email with registration link. You can please make sure you click on that. That'll add you to our mailing list so you can get information on more webinars coming up. Also, if you want any of our contact information, please shoot an email to the contact at Appleland Global, and we can reach out to you. Look for any of these folks at any of the next Big C training conferences. They're going to be presenting and talking over the same thing. Try to get a little bit more detailed discussion with them. I would also like to thank you all for reading off of all of the notes that we had. Hopefully, everybody could tell we're actually just talking like we would if you were right in front of us with our customer as one of our customers. So with that, we'll call it a webinar. Thanks again for your time and consideration.
Thank you.
Thanks.